All right, ladies and gentlemen, how are you all doing today? Let's go back. All right, there we go. Okay, so today what we're going to be doing is we're going to be talking about matrix operations. This is going to kind of be the next sort of step we're going to take in terms of solving these systems using a matrix. What we're going to kind of look at the next couple of days is going to kind of seem like almost a sidestep where you're going to see, well, why does this have to do with solving these systems, like where are we kind of going with this? But eventually we're going to see some of the power that are behind these matrices that we can use. But in order to get there, we have to first talk about these matrix operations, which is going to basically be how do we add, subtract, multiply, and all this other stuff with matrices. Okay, so the very first one we're going to talk about is called scalar multiplication. Okay, so scalar multiplication is when you multiply a matrix by a number out front. Okay, and basically all you do is you multiply each element by that number. Okay, so for example, if I take a matrix, let's say I have this matrix down here, and this matrix is 3, 5, negative 4, 1, I would say, all right, I want to multiply this by 9. All I do is multiply each element by 9, and then I'll get my new matrix. So it'll be 27, it'll be up here, 45 will be right here, negative 36 will go right here, and 9 will go here. That's scalar multiplication. That's all you do. You take the number, multiply by each element, and there's your answer. Scalar multiplication is one of the easiest operations we can do with matrices. Again, it's just multiplying each thing. As you can see, there's going to be a little bit more stuff that comes up with some of the other operations we're going to do. We're going to skip those for right now. Addition. Okay, now addition. In order to add matrices, all you have to do is add to like elements, but they must have the same order. Now, if you remember what I mean by that, basically they need to be the same size. So if I have, example here, a 2 by 3 and a 2 by 3, I am allowed to add those. They have the exact same size. They have like elements for me to add. If they are not the exact same size, you'll notice that you don't have all the same like elements and you can't go ahead and add them. Okay, so for this one, because same side I can add it, and again, all I do is add the elements that are alike. So for example, up here, this would be element 1, 1. This is also element 1, 1. Row 1, column 1. Those two get added together and become my element 1, 1 of my new matrix. And just kind of go through and do that. 1 plus 1 will give me 2. Negative 4, negative 9 give me negative 13. 4 and 2 will be 6. Negative 7 and 4 will be negative 3. And 0, negative 11 will be negative 11. And that would be my matrix when I go ahead and I add it. Okay. Then here's some more examples for this. So for this one, we have a 2 by 2 and a 2 by 2. I'd add these together. If I add these together, I would get 5, 7, 5, and 7. Hey, look at that. Okay, so that would be, again, adding the like elements and doing it. Here's an example of what I was talking about before in terms of something where we might have a problem. So here I have a 2 by 3 matrix, right? There's 2 rows and 3 columns, 2 by 3. This one is a 3 by 2. These are not the exact same order. They have different sizes. 2 by 3 and 3 by 2, not exactly the same. Therefore, I can't add these together. There actually is no answer to this. Okay, no answer. You can't do it. Okay, this is not something that is possible. And here's what I mean by that. Look, if I tried to add this 1, 1, and 1, 1, okay, I'd get 1, I get negative 1. Negative 5 and 7, I'd get 2. And then 2 and, oh, wait, what am I adding it to? So there's no like element over here to add this to, and that's why this is something that does not work. Okay, and that's something that's a little weird about matrices. They're different than our normal numbers. You can't add everything together like you can with normal numbers. We never think to ourselves, am I allowed to add these together when we're adding with numbers like normal? But with matrices, we have to always think to ourselves first, are these two things I can actually add together? Okay, they are, let me add them, or oh, they're not, I'm not going to add them together. Okay, so that's addition. And again, addition, subtraction, same rules. You would just subtract each element, that sort of stuff. Really, where we're going to kind of be headed, and the thing that's really interesting for us is going to be multiplication. And that's not the same thing as scalar multiplication. Scalar multiplication was multiplying just by a number. Matrix multiplication is going to be when we multiply a matrix by another matrix. Okay, and again, we're going to have some issues with this where we need to make sure that the orders line up in a certain way so that we can do it. And basically what that means is that the columns of the first matrix you multiply by have to match the rows of the other matrix. So, for example, if I have, let's say, a 5 by 3 matrix, and I want to multiply it by another matrix, that matrix needs to have 3 rows. That way the columns of this one and the rows of this one match up. I always like to say when you're multiplying the two, you should be able to circle these two numbers, and they should be exactly the same. When we do that, so here I gave the example of an m by n and an n by p matrix being multiplied, the order of the new matrix would be m by p. So basically, these things disappear, and my new matrix would be a 5 by 2 matrix. If you're asking yourself, Mr. Guy, what is the process that makes this matrix look so different? Don't worry, we're going to look at that in 1 second. Okay, so basically you take the rows of the first one, the columns of the second one, and that will become your new order. And that's based off the columns and the rows matching up in the middle here. Now, that means that matrix multiplication is not commutative. Again, a little weird because we're used to our normal number system where we have commutative property for our numbers. But we don't have that with matrices. So for example, in this one, a 5 by 3 and a 3 by 2, if I try to flip the order that I'm multiplying in and have a 3 by 2 times a 5 by 3, these two numbers do not match up, so this would have no answer. I can't multiply. So again, it's really important that we pay attention to the order they want us to multiply in addition to how we do the multiplication and everything else, to make sure that we can actually get an answer from our multiplication. So let's walk through the steps on how to do this. And this is what we call row by column multiplication. It's kind of a little bit of a weird process. So take a look at kind of what we're going to do here and follow along with me. So this first one here, let's take a look at how we would do this. So first thing I want to do is make sure that I can multiply these matrices together. Here I have a 3 by 2 that's going to be multiplied by a 2 by 2. And luckily enough for me, these two numbers are going to match up, which means, yeah, we're good. And my resulting matrix is going to be a 3 by 2. So I know already that my final answer is going to be a 3 by 2 matrix. Now, what are the elements of that 3 by 2 matrix going to be? Well, what you want to kind of do is look at each element that you're trying to get, and basically the way you're going to get that is by doing the row multiplied by the column. Here's how that works. So for example, I want to fill in this spot right here. This would be element 1, 1. It's in row 1, column 1. How do I get that? I take this row and I multiply it by this column. And here's how I do that. I do negative 1 times negative 3. That would get me 3. I do 3 times negative 4. That gets me negative 12. And then I add those two numbers together. 3 and negative 12 gives me negative 9. That would be the element that goes there. Row 1 times, or row 2 times column 1 would be element 2, 1 right here. 4 times negative 3 is negative 12. Negative 2 times negative 4 is 8. And I would add these together and I would get negative 4. Row 3 times column 1, 3, 1 would be the element right here. 5 times negative 3 is negative 15. 0 times negative 4 is 0. And negative 15 plus 0 is negative 15. Do you guys see how I'm getting that number? So for these ones over here, these would be, this one right here would be row 1 times column 2, because it's 1, 2 would be the element here. So row 1 times column 2, so I'm going to have negative 1 times 2 is negative 2, plus 3, which will be 1. And then for this one, 2, 2, 4 times 2 is 8. Negative 2 times 1 is negative 2. And so I'm going to get 6. And then last but not least, we're going to have 10 for this one. 5 times 2, and then 0 times 1. And there's my answer. Now, if you notice, I ended up with a 3 by 2, which is what we said in the beginning we should get. Because row times column, 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 ended up with a 3, 2, and that's what we said would happen. Here's what I'd like you guys to do. I'd like you to go ahead and try this second one that's listed here. I'll pause the video. You guys try this one on your own, and then meet back with me and make sure you have the same answer and you understand the process here. This process is going to be very important. It's what we're going to be practicing a lot this week, so I want to make sure you guys are okay with that. So go ahead, pause the video, and go ahead and try that one right there. Okay, and I'm back, and here's the answer that I came up with: -5, 7, -3, and 6. If you notice, we have a 2 by 3 being multiplied by a 3 by 2. Those middle numbers match up. The rows of, or the columns of this one match up to the rows of this one. So we know we're going to end up with a 2 by 2 matrix, which is what I got over here. I got this element by doing row 1 and column 1. So 1 times -2, 0 times 1, 3 times -1. So -2 and -3 end up being -5. And then I go ahead and did 1 times 4, 0 times 0, 3 times 1, 4 plus 3 will end up being 7, and that would be that element, so on and so forth to get this entire matrix from doing the multiplication. Okay, here's some more I want you guys to try. So again, if you guys want to go ahead, pause your video and try these and see if you get the same answers that I'm going to get. So go ahead and try these and see what happens. All right, welcome back. Here I have my answers here. So this is kind of what's really cool about matrix multiplication. You get some weird answers you might not be expecting. So like for this first one, these are two really small skinny matrices, and yet it's a 3 by 1 times a 1 by 3. Those match up, and I should end up with a 3 by 3, and that's actually what I got here. So basically, this is row 1 times column 1, row 2 times column 2, so on and so forth. Okay, and that's what gave me these answers to fill in. So I got 2, and then I got -4, and then -6, and then so on and so forth. Here I went ahead and did the same thing. It's 2 by 2 and a 2 by 2. I ended up with a 2 by 2 matrix, is what I'm going to get after these middles cancel out. So 5 times 1 plus -8 times 0, I get 5. 5 times 0 plus -8 times 1, so on and so forth. Now, you might have noticed something weird about this answer, especially if you got it before you checked with me. You might be like, Mr. Guy, that answer looks very familiar. In fact, it's this matrix right here. That is because this matrix actually has a special name. This is actually the identity matrix. Okay, it's the identity matrix. Kind of like how in our normal number system, 1 is the identity. Anything times 1 is itself. This strategic ones and zeros, we call the identity matrix because anything we multiply by actually gives us whatever we're multiplying. So in this case, I multiplied that matrix by this ones and zeros, and I got the same matrix again. It's acting kind of like a 1 does in our normal multiplication. You also may recognize that we've seen a matrix with 1s in the diagonal and zeros everywhere else before. Those two things might be connected. I don't know. We'll have to see that later. That's kind of your video for today, guys. So if you please go ahead and look through the work, you're going to be working through doing some of this adding, subtracting, and multiplying with matrices to kind of get used to doing these operations. Thank you guys for watching, and I hope you're having a nice week.